What is up, my Algebra 2 peeps? This is a review of radicals. So first up in our review of our radicals is simplifying. Okay, remember we can split up all of our constants and our variables. So I'm going to separate this into the cube root of 48 times the cube root of x to the fifth. Okay. When we simplify our constant, we want to first see if 48 is a perfect cube. It is not, so I need to find a perfect cube factor of 48. Okay, so when I do that, okay, 48 has a perfect cube factor of 8, and 8 times 6 is 48. Okay, now for my variable for this piece, I need to ask myself, how many times does the index go into the exponents? Okay, in this case, our index is 3. 3 goes into our exponents one time. Okay, 3 goes into 5 once. So to simplify that, I have an x to the first power. I don't need to write to the first power. Inside the cube root, I still have an x squared. Okay, it reduced by 3. Okay, so the remainder inside our radical is 2. If we remember back to the first time when we learned this, I wrote it out as the cube root of x to the third power, and those canceled out, leaving me with x to the first. What was left was x squared, using our exponent rules. Okay, to finish this guy up, the cube root of 8 is 2. I'm going to bring along any other non-radical terms, so I have that x. And then I'm going to write down, okay, the cube root of 6 and the cube root of x squared I still had. Okay, so that's the next step. Our last step, I can push any like radical underneath the same symbol. So I had 2x times the cube root, and I have 6x squared. That's my final answer. Okay, next we moved on to our operations. The first problem, we have an addition. Okay, and then we've got our division on the right side. When we add and subtract, okay, we need to have the same index with the same radicand. So I'm going to write that down. We want to have the same index on all of our radical symbols. In this case, both of my indexes are 2's, which is good. And I need to have the same, I could spell, same radicand. That's the number underneath the square root symbol has to be the same in order for us to add these together. Well, let's simplify. The square root of 48, that's not a perfect square. Okay, but it has a perfect square factor of 16. So I can break this up into the square root of 16 times the square root of 3. 16 times 3 is 48. Okay, so that will lead me to having a simplified root. I still have this plus sign. I'm going to ignore the 5 for right now. I'm just going to bring that along for the ride. Let's simplify the square root of 12. It's not a perfect square, but it has a perfect square factor of 4. The good part is 4 times 3 is 12. Both of these terms, here and here, have a square root of 3. That's going to help us. Okay, we're going to be able to add these together. The square root of 16 is 4. I still have root 3 next to that, plus my next term, 5 times the square root of 4 is 2, and I still have my root 3. The next step, I can't do anything else with 4 root 3, but I can multiply my 5 times 2. That's 10 root 3. Okay, now I have my same index, they're still square roots, and the radicand is now the same. They're both a 3. So I can add the constants in front together to get 14 and root 3. Okay, when we're dividing, we can squeeze these together if the index is the same. Since they are both an index of 3, I can push them underneath the same radical symbol. So I'm now going to have just a fraction inside of my root symbol. So on the top I have 16x to the 10th over 2x squared. And now I can start to simplify that. Okay, that's going to equal the cube root of, I can simplify my constants. 16 divided by 2 is 8. Now if I remember my exponent rules, x to the 10th over x squared, I subtract those exponents. Or, where are there more? Okay, there are more exponents on the top. Okay, there are 8 more of them, so I have an x to the 8th in the numerator, or 10 minus 2 gives me that 8 for my exponent. Okay, so I've got that the inside, the radicand simplified. I can now simplify the radical. Okay, I'm going to split up my constants and my variables, x to the 8th. Okay, the cube root of 8 is 2. Just like the problem on the previous slide, we were talking about how many times does the index go into the exponent. That's how we'll simplify this root. Well, 3 goes into 8 twice, so I've got an x squared with a remainder of 2. Okay, so that's going to be my final solution. Again, that when I simplified this guy right here, 3 went into 8 twice. That left me with 6. Okay, 3 times 2 is 6. So when I factored that x squared out, I was left with an x squared inside that radical symbol. And our last bit, okay, we want to solve an equation involving a radical. Okay, we want to do our order of operations backwards. That's our PEMDAS backwards. Okay, we want to solve for x, getting rid of our addition and subtraction first, then our multiplication and division, followed by exponents and parentheses. Okay, so the first thing I have to do is undo this addition by subtracting 5 from both sides. I am left with 2 fourth roots of x minus 5 equals, and 9 minus 5 is 4. Okay, and I don't need this first equal sign. Okay, so I took care of addition, I don't have any subtraction. Now I'm going to undo any multiplication or division. Well, I have 2 times, okay, 2 times the fourth root. Well, to get rid of that, I'm going to divide by 2. So I've got the fourth root of x minus 5 equals 4 divided by 2 is 2. Now, to get rid of our radical symbol, okay, the inverse of our fourth root would be to the 4th power. That's how we get that to cancel. So our index and our exponent are gone. X minus 5 equals 2 to the 4th is 16. I'm now inside my parentheses, technically, so I can finish off my problem by adding 5 to both sides. That gives me an answer of x equals 21. We should check this. Okay, 2 times the fourth root of Okay, 21 minus 5 plus 5. Okay, should equal 9. Well, 2 times the fourth root, 21 minus 5 is 16, plus 5 equals 9. 2 times, well, you can either go to your calculator or a roots table. The fourth root of 16 is 2, plus 5 should equal 9. 2 times 2 is 4, plus 5 does in fact equal 9. So I checked my solution. We want to make sure we don't have anything extraneous. That's it.